Um, Hello everyone to this was the third class now. This third class of advanced Python programming. Um, let's see. So before I get on with the lecture, there's just I'd like to go over the homework from the first class. So we could go over that together, and then we could talk about any questions that anyone has. Okay. So as a bit of a refresher of the homework from the first class, the task was to take a user input value and assign it to the variable x, and then set variable y to 10, and then check x in your code. If x is less than y, loop n from 0 to x, and then print out n plus x within the loop. If x is greater than y, then loop n from y to x and print out n minus y. And there's some error handling stuff too. So let's go over the solution that I wrote up a while back, and then we could talk about if there's any confusion. Okay, so the first objective with the homework was to set x to be the user input and set y to 10. So this part of my code here is what does that. So going over this code, I have a while loop. And then I set x to be the input of whatever the user wants. And then in this code block from lines 5 to 9, this is where I do the error handling. So what I do is that I try to set the variable x to its integer version. And if there's an exception, then I say that's not a valid input, then try again. If it is okay, then I just exit the loop. So if I were to run this code, let's run this code. Enter value from 0 to 30 inclusive. Let's enter 5. And the code runs as one would expect. It goes down to this if statement here. Since x is less than y, then this stuff in lines 14 and 15 is what's done. If I were to run this again and put in, let's say 20, which is greater than 10, then we have the stuff in the else if x is greater than y. Yeah, I do n minus y for n in range y to x plus 1. And yes, and lastly, if I put in a value that's not in between 0 and 30, well, like, or rather a value that's not an integer, if I put in gibberish, let's put in gibberish here, then we have gibberish is not a valid input. Please try again. If I put another non-good input, then I get the same thing, not a valid input. Yes, and if I were to put in, say, 10, and then that's it, then the code finishes because it's a valid input. Actually, it's kind of weird that since I put in 10, it doesn't do either of these if statements. So I guess that's a little bug, because I don't have a case for if x is equal to y. Anyway, yep, this is my solution to the homework, and I also posted this in the Google Classroom so that you guys can take a look at it and use it as reference for your own stuff. Any questions about my solution? All right. Okay, now we can go ahead and finish the lecture from last class. So we left off at date time, I believe. Yep, we left off here. Okay. So to give a quick refresher on what we talked about in the last class, we were working with time in Python, how Python handles time. how Python handles dates, and how Python handles calendars. So we have another module in Python that does things related to times and dates, and the module is called date time. So to handle date and time more effectively, Python provides another module, date time. So we could spend a minute or two looking at the methods in date time. I'll post a link to this in the chat as well. Let me see. All right. So the datetime module supplies classes for manipulating times and dates. Let's see. Looking for some methods. So we have the time delta, which is another way of handling times and dates. What else do we have? Time delta seems to be the main thing and the main way that this module handles times and dates. We have total seconds. We have date objects. So yeah, a lot of documentation here. I'm sure we'll be working with some of the things on this page as we go along with the rest of this lecture. So datetime. All right. Let's let's import the module and give this code a go. All right. So in this code block, we have x, variable x, and we are setting x equal to datetime.now. And then we're printing out some values associated with x. So let's give this a run. All right. So x is just equal to the current date and time all the way down to the millisecond, it looks like. Yeah, all the way down to the millisecond. And then if we do x dot year, then we get the current year. And then if we do x dot string f time, it looks like string f time, and then we pass in %a, that gives us the weekday. I'm sure we'll make more sense of this string f time method, but so far this looks like a pretty clean way of manipulating dates and times, because all we have to do is just set x equal to datetime.now, and then we're able to access the different parts of the date. We can also set x equal to this, to date time. So if we could put in a year, a month, and a day, it looks like. So let's try this one out as well. All right, so we're setting x equal to datetime.datetime, and then we're passing in the year, the month, and the day. So by printing x, we get what we put in pretty much in a nicely formatted way. Let's see what else we can do with date time. Oh, wow. Okay. So this requires some more imports. So if we remember from last class, there was some issues with trying to get trying to work with dates that are before the first epoch. So datetime has a way of making it so that we can work with dates before the first epoch. So January 1st, 1970 is the first epoch. That's when time starts, according to Python. So if we add time delta and then we pass in seconds and then a negative number, we can get a date that's before the first epoch. So by writing this code, we have the year 1963, February 23rd, and we're able to get back before the first epoch because of the time delta right here. We have the time delta method, and then we pass in seconds is equal to this really big number. And that what that did was that subtracted the first epoch by this much seconds, and that's all why we got this date down here, 1963. So does anyone have any questions about what we've seen so far? All right. Yeah, there'll be exercises that we'll be working through together. So date time still has a min and max value it can support. So let's see, if we try to put in this number or this date time, it's probably going to be too big, but let's see. So we're setting x equal to date time in the first epoch, so 1971, and then we're adding the time delta of this many seconds. Are we going to print x? Let's see if we get an error. Yeah, we do get an error. Okay. So can anyone tell me, or can anyone give a guess as to why we're getting an error when we try to run this line right here? This last line, x equal to date time plus time delta. Yep, Henry?
I think it's because it's like too many seconds for.
Yep, that's it, 20 seconds. So date time still has a max value. So we're trying to put a date that's too far into the future. If we were to remove a few digits, let's say that many digits, then this should work. Yep, we don't get an error now. Let's print x. Yep, so it works now because we removed some digits. But if you were to add this digit, the digits back, then we'll get an error again because the date value is out of range. Right? Does that make sense to everyone? All right. So we have a little thing. Please find the min and max value between 1 and 9999. I am not sure myself what the min and max value would be. We could try out some values. Let's see, let's remove 2 digits. Let's see if that gives us an error. All right, it didn't. Let's remove 1 digit. No error. If we add another digit, that gives us an error. So we can say that the max value is, let's count the digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can't have more than 12 digits, it seems, or else we get an error. Yep, we can't have more than 12 digits. And then we could also say that we can't have, it'll be the same in the negative direction. We can't go back in time more than 12 digits, or else we'll get an error. Right? We can say that. We test it out. Let's see what happens. No error there. Maybe another 0. Yeah, and now we get an error. Yeah, so we can't have more than 12 digits, it seems. All right. So the time module is principally for working with system timestamps expressed as a floating point number taken to be seconds since the epoch. The date time module can support many of the same operations, but provides a more object-oriented set of types, and also has some limited support for time zones. So the main thing to get out of this slide, so the stuff we talked about in the beginning of the last lecture with the time module stuff, that's mainly for working with like not the raw number of seconds after the first epoch, essentially. And we can think of the datetime module as a more user-friendly way of working with time in Python. That's essentially what the slide is saying. Okay, now homework for we'll call this lecture 10. Find the movie star you like, get his or her birthday, and then convert it to a time object. Remember how to get a time using time format. Now use this time and get its year and month and print out the calendar for that month. Make sure the first column is Sunday. Okay. Does anyone understand that assignment? Any questions?
How do you print out a calendar?
Yeah. So in the last lecture, we had some code for printing out a calendar. So I could refer you to that. Let's see if I can find it quickly. But yeah, there is a way to print out a calendar in Python.
Oh, okay. I'll just look in the class notes.
Okay, yep. Yep, it's there. Right. Any other questions? All right, then we can move on to the next lecture. They'll just give me some time to make the homework assignment and post the last bit of notes from this section. All right, so almost there. All right. Okay, on to the next lecture. All right. Let's see. So this is lecture 3 for or class 11. Let's see review. Well, we just wrapped up the last few bits of the last lecture, so we don't need much of a review. What is the epoch for Python time? Can anyone tell me what the epoch for Python time is? What the first epoch is? Or what year the first epoch is? Yep, Henry?
Is it 1970?
That is correct. Nice job. Yep. How many items does a struct time object has for a time, and what are they? Uh, you guys can just look back at the notes to answer that question, but I don't know the exact number of items off the top of my head. I think it's around maybe like 8 or so. What are they? Can someone give me some examples of some of the items in the struct time object? Yeah, so some stuff is like the year, the month, the day, the weekday. I think maybe the time zone. Actually, I don't think the time zone. The day of the week. I might have said that already. But yeah, the struct time object has a lot of stuff in it. Some stuff in it. All right, anywho, let's get on with the lecture. So we will finally be talking about functions today. So let's try some code to find z's value. If x is greater than y, z's value is the sum of x and y. Otherwise, it is the non-negative difference of x and y, and then we have some cases. So let's think about this for a second, and we could try to figure out how one might go about coding something up to do this. So if x is greater than y, z's value is x plus y. Otherwise, it is the difference between x and y, the non-negative difference. We have two questions. So we can say that we would definitely use an if statement, right, in order to do this. Yeah, we'd use an if statement. And that's really all we need. So let's see what, yeah. So the way to do the problem would be we'd set x equal to something and y equal to something. And then if x is greater than y, then z is equal to something else, z is equal to something else. Pretty basic stuff, I'd say. Stuff that we've gone over before. Writing the code on the previous slide obviously is not good enough for us if we need to find out z's value if now x is equal to 10 and y is equal to 20. The reason is that we have to write those condition statements again. So to solve that, I mean, does everyone understand the problem? So this code works as long as x is greater than y, but we don't really have anything if y is greater than x. Because we'd have to write another condition. So how can we get around this problem of having to write another condition?
No.
Yep.
Wait, I was gonna ask for you to go to the side.
Were you what?
I was gonna ask for you to go to this slide, but you just.
Oh,
so.
yeah, okay. Yep, so the problem is that we have a case for if x is greater than y, but we don't have a case for if x is less than y. So this code isn't good for all cases. So of course we could just write another conditional statement, but like another else if, but maybe there's another way that we can solve this problem. So to solve that problem, Python functions come into play. A function is a block of code that can achieve a specific goal. Usually a function will return a value for use by the caller. Functions are defined by the def keyword, followed by the function name and a list of parameters. So this slide's talking about what a function is and why it's used, essentially. So this right here is the format of a Python function. And we could break down the syntax together. So this is a function. So we have def, the word def, followed by the name of the function, some problem. And then we have a parentheses and then x and y, followed by a colon. And then we pretty much just have our summation and our answer. And I think the next few slides will talk about what this is, so I don't want to get ahead of myself. Okay. So right now we have our functions, some problem, and then some other syntax. So now we have to use it, and we could use this function or call the function is how we usually describe it. We're calling a function. We can call the function by doing problem, the name of the function, followed by a value, let's say 10, and then another value, let's say 5. or 6, we'll use 6. And then if we run this, we get our answer. Yeah. And let's just take, whoops, well, let's just take what we have here and play around with it. So we're calling some problem with a few different arguments. So what these values that I'm passing in, they're called arguments to the function. So the arguments for the first sum problem that I'm calling is 5 and 6. The arguments to the second one is 12.5 and 16. And the arguments for the third call is ACD and BCD. So if we run this, it should all work. Yep, it's able to do the integers, the floats, and the strings. You guys see how useful this is? So we don't have to like write a condition for each and every possibility. We can just write a function that is able to kind of write a general blueprint for what we want to do, and then we could call it for whatever things that we want, if that makes sense. Does anyone have any questions about how a function is defined or how we call it? All right. So we have another function called getCommon. So this function tries to find the common characters in two strings, and it returns a value. So this is different from the first function that we created. Oh, one thing I'll mention. So in Python, the convention or the usual way that we code in Python is that we put all the functions on the top of the program, and then everything else is on the bottom. So right now I have two functions at the top. So I added another function called getCommon that takes an x and a y, but this time we are returning something. We're returning a z. So what this will do, if we were to call getCommon, Python will give us back whatever, or rather, the function will give back the thing that we're specifying. So in this case, we are returning the variable z to whatever is calling this getCommon function. All right, and remember that getCommon is just finds the common characters in two strings. So the way to use this function, let's try this out. We're going to create a variable z that is equal to, we're setting the variable z equal to getCommon. So we're passing in write code and drink water, and then we're going to print out the value of c. So make sure to, or rather, take a look at the syntax that we have here. We're setting the variable z to a function. getCommon. At first, we were just calling the functions by themselves, but now we are setting a variable equal to a function. Now, can anyone tell me why we're setting z equal to a function? What's so special about getCommon? Right, we're setting z equal to getCommon because the function getCommon returns a value. So that value has to go somewhere. Okay, that's why. So we're using z to store or receive the value returned by the function, then print out z. So if we run this code, I gotta comment this stuff out first. If we run this code, we get that the common characters in the two arguments that we passed in was WETID, a space, and R. That's what the value of Z is. Now think about the problem we ran into in the beginning of today's class. Spend 5 minutes and write a function to find Z and return Z's value. All right, so let's work on this together. Let's go back to the problem that we faced in the beginning of class. So in the beginning of class, we had an issue if x was less than y, the code wouldn't work, or rather if it was equal to y. Actually, no, this else should take care of that. Okay, I think the issue is that we weren't returning anything. So let's write a function that implements this stuff. Let's call the function. Actually, I'll let you guys decide. What should we call the function that solves our problem? The function that's doing the stuff that we have on the slide here. What should we call it? There's no right or wrong answer. It's just preference. Oh, I have an idea. Let's call the function fun. So our function takes an x and a y. And then we're going to return z, else do this and return z. And yeah, right. And this code solves our problem because now we're getting the value of z back. And one little thing I'll note, it is possible to have more than one return statement in a function. So here I have two in both of the else blocks. So if I give this guy a run, let's make z equal to fun 10, 6, and we print z. We got 16. And yeah, so does everyone see why this code works? We pretty much took what we had on the slide and then we added a return statement to it. So that we can get the value of z back, and now we can see the value of z. Oh, I should have asked you guys how we would call the function. Oh well, that would have been a good question. Anyway, we can move on. Oh, the function is called find z. Okay, I missed the name. It's supposed to be called find z. All right, find z. Okay. All right. See, you can define a function within another function. In this situation, the inner function is not visible outside of the parent function. Try to call in inner fun in this example, inner fun. All right, so we have stacked or nested functions now. A function and a function. So we have outer fun and inner fun, and now we have a return statement for inner fun and a return statement for outer fun. This might seem kind of confusing, but uh, there is some structure to this. So can anyone tell me, or yeah, can anyone tell me what the flow of this of this nested function is? Like what's called and what and in what order? All right, so first we're calling outer fun, and then when we get into outer fun, we're defining another function called inner fun. But we're not calling inner fun yet. So the first thing that we're doing is that we're returning inner fun AB, and then when we and then when we and then when this function is called that's when we go into inner fun, and then we return. It might seem like a lot, but let's just run the code and see what we get. So let's set z is equal to. So how would we call outer fun? The outer function. How would we call this right here? What would be the correct syntax? So the correct syntax would be z or any variable is equal to outer fun, and then we pass in some numbers. Let's say 10 and 4. So if we run and then we're gonna print z. So if we run this, we'll get 14. So can anyone tell me, looking at this function right here, why we get 14 when we run outer fun? Let me just move this up here for a second. Why do we get 14? Right, let's walk through this together. So the first step, we have z is equal to outer fun 10, 4. So when Python sees this line right here, this function call, come on, highlight. When it sees this line right here, it'll go to this line up here, line 22, and then it'll substitute A and B in outer fun for 10 and 4. Okay. And then Python will go down here to this line, return inner fun and AB. So A is still 10 and B is still 4. So after we go to line 25, then we jump to line 23, and then we make CD is equal to 10 and 4 because that's how inner fun is defined. And then inner fun goes to this line and it returns C plus D, which is 10 plus 4 or 14. And then we go back to line 25, and then we return 25. And then outer fun returns 25, and or outer fun returns 14 because 10 plus 4 is 14. And then we finally get back to line 27 here, and that's why z is 14. So there's a decent amount of jumps when we have nested functions like this. But it's very important to understand nested functions because they'll be very useful for object-oriented programming when we get there. Yeah, does anyone have any questions about that nested function? All right. All right, we have another function here, def last first. Let's see what this one's about. All right, so this function looks a lot like the previous three that we've created. The main can anyone spot what the main difference for this function is? How it's different from the others that we've been working with so far? How is this function different? I'll give you guys a hint. There's something in the arguments list that's different. Right. The difference is that we're setting one of the arguments equal to a value. So in the preceding examples, we didn't set any of the arguments equal to anything. They were just there. But this time we are setting one of the arguments that we're calling separator equal to, in this case, a comma. So what this will do is that we're setting a default value for this argument for separator. So if we run this, so if we call last first and pass in some values, what we get is Smith Tom. So we're essentially just swapping the last name for the first name. Yeah. Any questions about that? Any about having a default argument for a function? All right, let's move on. This function has three parameters. Okay, so one thing I'll say, there, there is a subtle difference between the word parameters and the word argument. So arguments are the values that we're passing into a function, while the parameters are the parameters of a function are the variables. So let's take outer fun, for example. The parameters for outer fun is A and B. The parameters are A and B, while the arguments for outer fun in this case down here is 2 and 3. So arguments are values, parameters are variables. Those are the difference between that's the difference between the two. So why can we call it by supplying this one parameter value? The default value is defined. Please refer to it back and find which parameter has a default value. All right, so here's an easy question. So looking back at this function that we defined last first, which argument has, or which parameter has a default value? Is it first name, last name, or separator? Does first name, last name, or separator, which one of these is the default value or has a default value? All right. It's separated but has a default value because we're setting it equal to something. We're setting it equal to a comma. Um, the default value is evaluated only once. This makes a difference when the default is a mutable object, such as a list, a dictionary, or an instance of most classes. For example, the following function accumulates the arguments passed to it on subsequent calls. What does this mean? We'll see. So we have this example. We are defining a function that's called f that takes a parameter a and a list, and L, that's an empty list. Let's put this in our code. So we have function f, we have parameter a and parameter L, and L is just an empty list. So we're appending a into L, and then we're just going to return L. Pretty straightforward. So if we call this, okay. So can somebody tell me what will be printed with this first function call that I have here? So if we pass the value of 1 to f, what's gonna be printed? Um, okay, maybe we need some help. So the first thing that's gonna happen is that when we call f of 1, like f parentheses 1, we're going to go to this line here, line 31, to the function call, and we're going to replace a with 1, and then we have L, so which is just an empty list. So we're going to append the value of 1 to L. So if we were to run this, I'll comment out the rest of the stuff. If we were to run this, we'll just get 1. Can everyone hear me okay?
Yes, we can hear you well.
Okay. So if we just pass in 1, then L, then we're gonna append 1 into L, which is just an empty list, and then print it. Okay, any questions about that? About why that is so? Okay. Here's an easy question. What would happen if we were to call this second function? But instead of passing 1, we're just gonna pass the value of 2. What'll be printed instead? What'll be printed instead of passing in 1, we pass in the value of 2. Oh, we get 2 because we're just swapping a value. We're just gonna append the value of 2 into our list. And the same thing for 3. Oh, Oh. Oh, I see. Okay. All right. So I made a slight error. So when we have a default value like this, it stays in place in between function calls. So since we call f of 1 first, we add 1 to the list. And then when we call f of 2, we're getting 1 and 2 because the original 1 is still in there. And the same thing for 3. That's why we're getting this output where the first one is just just a list with just 1 in it. Second one is 1 and 2, and the third one is 1, 2, and 3. So that surprised even me. I did not think that would happen. But yeah, any questions about this? Keyword arguments. When you use keyword arguments in a function call, the caller identifies the arguments by the parameter name. This allows you to skip arguments or place them out of order because the Python interpreter is able to use the keywords provided to match the values with the parameters. This will make more sense when I run the code because there's a lot of new words that were introduced here. So let's define a function. We're defining a function called print_info. So this looks like how we've been defining every other function so far. Yeah, nothing out of the ordinary here. But the difference comes from how we are calling the function. So instead of just passing in some values and leaving it at that, we are using keyword arguments. So for print_info, we're making age equal to 50 and name equal to Mickey. And we're able to do that because we have the parameter names here. So we're using the parameter names and we're setting their values explicitly. So can anyone tell me what the main advantage of using keyword arguments is? Why would this be better than just passing in values without any keywords? Yep, Henry?
Is it more efficient?
Able to do that because we use the keywords first. We're setting age equal to 50 and name equal to Mickey. If we were to remove the keywords, we're gonna get an error because we're trying to. Oh no, it worked. It worked, but it's not. It gives us an unexpected output because name shouldn't be 50, should be Mickey, and age shouldn't be Mickey, it should be 50. So we need the keywords in order to make this actually look correct. All right, exercise. How much do we have left? Okay, a few left. So a company needs to pay its contractors weekly. A contractor is paid by his or her hourly rate and the hours worked. An HR person needs a function to get the total payment to each contractor if this person knows the hourly rate and the hours worked. If the hourly rate is not available, then the contractor is paid a minimum wage of 11 per hour. Can you help the HR person? Is there an answer for this? Okay. So yeah, a lot of stuff in this exercise. See if we can go through this together. I'm debating whether or not I should go over the solution now, or if I should leave this exercise as something that you guys think about this week, because I think you guys need more practice when it comes to functions. Yeah, you know what? I'll make this an exercise on the Google Classroom so that you guys can get some more practice. But I'll go over some of the first steps. But we'll go over the first step together. How about that? So let's make a function called def x1. I'll just make the skeleton for it actually. So we have def x1. How would I do this? So I'll just make the skeleton for this, and then I'll have you guys fill in the blanks on your own time. That way, you're still getting something out of this exercise, and you'll get the practice that you need. So I may need some time to think about how I would make the skeleton for this, but I'll post this on the Google Classroom, and then we could, and then yeah, I'll post it sometime this week actually. A midweek exercise so that you guys say reviewed and stuff. But there was a lot in this lecture where it's almost 7:30 now. You guys were unusually quiet today, which tells me that maybe not that the material was kind of hard to understand, maybe. Does anyone have any? Okay, I've asked that a lot, but on a scale from 1 to 5, let's say, how comfortable were you guys with the material today? Just say in the chat. On a scale from 1 to 5, how comfortable were you with the material? Okay. I guess you're hungry for pie, Henry.
Not really.
Yeah, I think having some practice over the week will really help you guys understand some more stuff. But yeah, I really encourage you guys to look over the code some more. Look over the video lecture when it's posted. And yeah, I think I'll just end the lecture here. So yeah, it's 7:30 now. So yeah, thank you guys for coming to this lecture. Again, I'll post the exercise for you guys sometime this week, and I'll make some skeleton code. So all you guys have to do is just fill in the blanks, and I'll make sure to comment it pretty well so that you guys understand what's going on. And we'll pick up where we left off from next week. We'll pick up from where we left off next week. And there is a homework assignment actually related to date times in Python. So make sure to do that. And yeah, anything anyone wants to say before we go? All right, we'll have a good rest of your week, everyone.